Normally, I like to stick to doing videos of the official FMWC battles, but every now and then, someone completely off my radar shows up out of nowhere and drops a really good case. So today, I'm making an exception and doing a walkthrough of a free case called Big Fish, written by Valy Greavu from Romania. I'll do a quick introduction of the case, and if you like what you see, there is a free download link so that you can try it out yourself in the description below. In the Big Fish 2025, the action happens on this ocean map divided into sectors. Each fish has a direction that they can swim left, right, up, or down, and we're going to simulate who collides as they swim. The early levels get us comfortable with the basics, counting species, identifying groups, and spotting dominant patterns. But the real mechanics come alive in levels 6 and 7. In level 6, it becomes a classic upstream versus downstream problem. When fish meet head on, the bigger fish survives and keeps going, often through a chain of battles. Level 7 adds growth. Survivors eat smaller fish and accumulate size until only one dominates the sector. The challenge is turning the map into a sequence of encounters and tracking who makes it out alive. Alright, let's get started. So this first level, we're just doing a basic count of the characters that are given. And this is a sort of a new twist here. Count characters, but there's an array of values given. So we'll just do a reduce. Split these by a semicolon. So it'll be A plus count character. Okay, this one we need to filter out the fish. We only want the ones with these directions. So first we'll deconcat. And we'll say filter those where the right value is in using this isNumber X match pattern, and we'll text split again the directions. That should get us the list of filtered fish, and then we need to look these up in the size. The size table is here. Let's turn this into a table real fast. And now we can XLOOKUP the left part of these to our table and sum them up. Alright, so here's an error on this line. I think it's because there's no left arrow in this direction. So I'm just going to wrap this in a if error, return 0. Good. How many species are present in the specified ocean sector? So now we have to care about the sectors here. First thing I'm going to do is just name this as a map. And second, after that, is scroll over to the side here, and we'll use a table lambda to turn map into this table that has address, row, values, etc. I'll copy paste values and then turn this into a table as well. Call it M. Now we need to find the sector. So the sectors are given by these merged cells on the top and sides. So the row sectors are 10 rows each, and the column sectors are 5 rows each. From that, we can add on to our table over here. So we call this sector. And the logic for that will be quotient the row minus 1 divided by 10, and then you add the 1 back. And we'll concatenate that with semicolon, and then do the same logic for the column. But there's going to be 5, divided by 5 instead. So that gets our sector. While we're here, we might as well just add in a couple more pieces of information, the species and the size. So actually, let's do icon, species and size. So the icon will be the left value of that. The size will be looking up the icon. And the species will be looking up the icon as well. Okay, now our table setup is done. Now we can just go here to our questions, equals filter species on M sector equals that. So that gives the list of sectors. We don't want herb, we only want the animals. So I'm going to add a secondary filter condition that says M size is greater than 0. So those are fish species. We're going to make this unique. I only want the unique values, and then to count those up, I'll use rows. Good. All right, level 5, the value per sector. I'm going to use a similar formula here, just tweak it slightly. So instead of rows unique, we want sum. And instead of species, we want to return the size. Between the two sectors, we just want the largest of the two. Good. Okay, here's where it gets pretty tricky. It took me a while to understand the directions here, but now that I do, it's not so terrible. First thing we want to do is filter the fish that are in the sector that's given. So we'll say filter M value on M sector equals that. And I think we need to do the same thing as before with the secondary filter on size. So M size is greater than 0. Okay, so we have, I'm going to zoom in so you can see this a little better. We have a stack of fish, and the instructions say that basically the left and the up arrow are together on the team, and the right arrow and the down arrow are on the downstream team. And so we don't really care the specifics. It's either upstream or downstream. It doesn't matter left, right, up, down. Upstream or downstream only. And the upstream go up the array and try to escape from the top. The downstream fish swim down through the array and try to escape at the bottom. If one team meets the other team as they travel, then they fight each other. One wins and one dies. So that's what how the model works. I'm going to change these initial values into integers, positive and negative, to represent upstream and downstream. So we'll do a left lookup of the left side, and look at the size of the fish. Those are the sizes. I also need a little table, a helper table, that show me the directions. So I have this already built into my lambdas, but I'm just gonna delete the directions that I don't need here. Okay, so this is downstream, downstream, upstream, upstream. And I'll call this DIR. And I'll call this range VAL. Directions and values. And I'll just move these out of the way. Okay, so I've got integers and I just want to multiply by the directions. So I'm going to go upstream or downstream. So we'll say x look up the right character of this stack, looking it up in direction return values. Okay, so now we have a numerical representation of the fish. And from here, basically I'm going to go in a round. I'm just going to go fish by fish and see what happens to that fish after the first round. So these positive values try to go up. And so nothing happens to these two fish. The negative value tries to go down. It will eat the 2. So the 2 dies. These guys, this guy goes down, but he's on the same team with this guy, so that's nothing happens to him. The positive 3 eats the negative 1, and nothing happens to these. So that's the logic that we're aiming for. The way we're going to tackle this is basically, if you're a positive value, we're going to check the value above it. If you're a negative value, we're going to check the value below it. So what I'm going to do is map. The values above will be represented by this V stack, where I'll drop the last value, so -1, and then stack it with a 0 at the top. All right. Then so that'll be the above stack. This is the regular stack, and then we need a below stack. So that's going to be V stack drop the first row and add a 0 at the bottom. Okay. So now we've got our lambda, and I'm going to start working up here. So A, B, C. No, let's see. We'll say above stack and below. So A, S, and B. Those are our values. So the first thing I want to do is say let, and we're going to say C is our compare cell, our comparison cell. So if the S is positive, then we want to look at above, otherwise look below. That's our comparison. So now we can say if either condition is true, if or the absolute value of stack value is greater than the absolute value of comparison value, greater than or equal to. If that's true, or if they're on the same team. If they're on the same team, that will mean that the stack times the comparison will have the same sign, so greater than 0. Negative times negative will be positive, positive times positive will be positive, positive times negative will be negative. So if those conditions are true, return our stack fish. Otherwise, the fish dies. I'm going to put NA for that, and that'll make it easier to filter after we're done. Okay, let lambda map, and on the outside we'll just say to call and filter out the errors. Okay, so as we expected, the -7 gobbled up the 2, and the +3 gobbled the -1, and everyone else survived. And we will carry out this iteration multiple times until it stabilizes and the positive fish escape out the top, the negative fish escape out the bottom, and we want to count up the remainder, which is 3, which is the answer here. Okay, so it would be a totally valid approach to do like a data table and just put an arbitrary number of executions out to the right. I actually want to try my hand at recursion, so I'm going to do that. So we're going to say let equals, here, let me scoot over more, I'm sorry. Okay, so here we are. I'm going to say up here let values be this, and then this becomes the new stack. So initial stack did something wrong. What is it? This one has to be referencing values. Okay. So here we have a map function that does the iteration that basically takes a stack and returns the next value of the stack. So we can turn that into a lambda and just take all the references and replace these with stack. And close the parenthesis at the end. That should be kind of all we need. So now we have, I'm going to define iterate as that lambda. And then we have to do the recursion. So let's give us a little bit more space here. And I have a recursion helper that's defined as a named lambda. So what we'll do is call, say, survivors will be recurse with a little bit of setup here. Now our main lambda is this stack, and we'll say let new stack be iterate stack. And then just like this is where the recursion begins. Recursive function always has like an exit point first. Well, it can be last, but I do it first. So we want if or what are the conditions where we want to stop at? We want to stop when it's done evaluating, like you do an iteration and there's no additional improvements in the stack size. So we'll say rows stack equals rows new stack, or if rows new stack equals 1. If either of those conditions is true, then return new stack. Otherwise, we'll do the recursion. And the way my lambda works is you say me, it's like a self-referential me to this function, and then return the parameter that we need to use. Let's lambda recurse, and then invoke the whole thing with the initial stack. Okay. And we're just going to see if we get this part right. All right, so that returns our survivors. And then the final answer is just a count of the survivors. And let's zoom back out. You can see that there's an error on this one right here. So let's see what happened. First of all, just check survivors. Survivors didn't work right. Let's check what our initial stack was. So the initial stack only had one value. I think that's the problem. Since our initial stack only had one value, we can't really iterate. We could fix iterate, or we could just bypass that whole thing. Just say if rows of the initial stack equals 1, then return 1. Otherwise, rows of survivor. And that still seems to work. Okay, good. Now in this last level, it's very similar to level 6. The difference is that the size of the fish grows as it eats the smaller fish. So we just make a couple small tweaks here. The main part is going to be changing this absolute value logic, because we don't want to return just the fish if it survives. We return just the fish if it's the same size, or if they're the same team, so that part stays. but otherwise we need to separate out this condition. So if it's greater than this, then we'll say the stack size minus the comparison size. And it's minus because they're actually opposite signs in all cases. So a positive number minus a negative number actually makes the absolute value larger, which is what we're aiming for here. So that works. And then the other part is we're not returning the number of survivors anymore. We're saying return the largest survivor, which we need absolute value for. And on this edge condition, instead of 1, we're going to just return what that value is, the initial stack. Okay. All right, and there we go. That was pretty successful recursion attempt. It doesn't always go that smoothly. Okay, now we'll do the bonus. Identify the most dominant marine species. I learned this through reverse engineering, but the answer, it's asking for the most common species in the map. So that's most of M species. In levels 1 through 3, excluding example cases, what is the occurrence value of the most common movement direction? Okay, so I need all the movements from levels 1 through 3, so I'll just say kind of like, I don't know, 2 row, all H stack, 2 row, levels 1 through 3. So it'll be this, 2 row, level 2 inputs, and then 2 row, level 3 inputs. Okay, and we can decatenate that. No, we can't. That didn't work. Why not? Interesting. I've never run into an error on my Lambda here. But that's okay. That's okay. Oh, this is an H stack. It's not a single string, so let's concatenate it first. And then deconcat. There we go. Alright, now if we just take the right value only, we get the arrows, and then we can say most of, and use that return count parameter to get the answer, 159. Good. Okay, in how many sectors are all species present? How many sectors are all species present? So let's do a group by table, and we'll say M sector, M species. Species. How do I do a count unique? Actually, I don't know how to do a count unique in this case. So I'm going to stack these together. Stack those together. And then just return like M address count A 0 0 -2. Okay, so that's a mini table of all the sector and species combinations. We don't want herbs. We add a filter to this to say M size is greater than 0. Okay. I'm not used to this. -3. Okay. Actually, it's not relevant yet. I'm going to do a secondary group by on this. Equals group by. This time we'll group by sector, and then just count up the values that are there. I think there should be a way to do like a lambda, like function where you don't have to do 2 of these, but I don't know how yet. So that's 9. We have 9 values that have the most. So I think that's our answer. What is the total value of the ocean fauna? So this is the total value of the animal size, like Adam wrote. So I guess let's just sum M size. And then identify the sector with the highest value map on the map. Okay, so the sector is going to be index group by M sector and size. We're going to sum that and then sort and take the first value. What did I do right here? Group by M sector, M size. I closed it out prematurely. There we go. So 24.5 minutes. That was a really good case. It did take me longer the first time, mostly due to reading the instructions poorly. But overall, that was amazing, Valy. I don't know you very well yet, but I hope to get to know you better because that was really good. Thanks, guys. See you next time. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.